With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, so we are given with a question which says a hydrogen atom in a state of binding energy 0.85 electron volt makes a transition to a state of excitation energy 10.2 electron volt. We need to find the energy and wavelength of the photon emitted. So basically we have studied the energy that has been associated with the orbit is given by the formula En, and that is equals to minus 13.6 z square by n square. Alright, so in this case it is an hydrogen atom, so the value of z will be 1. Therefore we can say En, that is energy of nth orbit, will be equals to minus 13.6 divided by n square in terms of electron volt. Alright, so if we carefully analyze, when n is equals to 1, we can say if we calculate when n equals to 1, so the value of E1, that is energy first of the first orbit, will be equals to minus 13.6. When n is equals to 2, the energy comes out to be minus of 10.2. Here minus sign is indicating that it is binded to nucleus. Alright, so that's what binding energy is. Now for n is equals to 3, if we calculate, so the value of energy comes out to be minus 1.5, and these all are in electron volt. So finally we can say when n is equals to 4, so the energy comes out to be E4, and that is equals to minus 0.85 electron volt. Alright, so if we try to visualize the condition, so this is how the energy looks like. This is n equals to 1, so it has an energy of minus 13.6. Here it is having a minus 10.2 electron volt energy. Here it is minus 1.5 electron volt energy, and finally we have minus 0.85 electron volt energy. Alright, so finally we can say that the electron is jumping back to the excitation, makes a transition to a state having energy 10.2 as per the question. So from this we can say it is having initially 0.85. So we can clearly see that electron was in fourth orbit, and from there it is making a transition to second orbit. So this was n equals to 4, this is n equals to 3, this is our n equals to 2, and this is our first orbit. So we can clearly see the orbit in which it was initially in, it was having energy of 0.85, so that means it was in a fourth orbit, and it is making a transition to orbit having energy 10.2 electron volt. That means it is transitioning to n equals to 2, second orbit. So therefore we can say, therefore by Bohr's third postulate, energy of photon that has been emitted from this photon has been emitted during the transition, so that photon's energy E, we can say, is nothing but it is energy difference of the two orbit, that is E4 minus of E1, E2, sorry. So this we are writing by Bohr's third postulates. Alright, so from this we can say E4, in terms using this formula we can write minus 13.6 divided by 4, that is 16. Minus and minus will become plus 13.6 divided by 4. Alright, so from this we can, if we solve it further, we can say 13.6 can be taken out as common. So we are left with 1 by 4 minus 1 by 16, and that gives us the answer as 2.55 electron volt. So this is what the energy of photon will be. Alright, so this is the first part, we have calculated photon energy. Now we have to calculate wavelength. So we know E is equals to h nu, that is energy associated with photon is E equals to h nu. So we can write now, this is nothing but it is energy with photon, energy of photon. Alright, so we can write nu, that is frequency, can be written as c over lambda. So from this we can say the value of lambda will be, this implies that the value of lambda can be written as hc by E. H is Planck's constant, that is 6.6 into 10 raised to minus 34 into velocity of light or speed of light, we can say it is 3 into 10 raised to 8 and dividing it by lambda, that is dividing by E we have calculated it as 2.55 electron volt. So that means 2.55 into 1.6 into 10 raised to minus 19 joules. We have converted into joules. So finally the result comes out to be for lambda as 5524 Armstrong. So this is what the value of wavelength we are getting. So I hope you have understood the concept well, and thank you for watching.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.